evaluate 1031 to the power 50. So 50 is big. I usually say anything to the 5 or to the 6 or beyond that is usually something. 5 and 6 are usually my limit. If it's 7 or 8, I'm probably going to start looking for a pattern, and certainly if it's double digits, okay, which this one is. So how do we do an exponent to something so large? There's no way I have time to write 50 of these out and multiply them all together. So that's where we have to rely on looking for patterns. So we'll take this matrix, raise it to the power 1, to the power 2, to the power 3, 4, 5, until we notice a pattern, until we can start predicting the next one. Now to the power 1 is always the easiest thing. Just take that matrix and write it out, really. What about to the power 2? Well, we don't just square each of the entries. You actually have to take 2 copies of this matrix and multiply them together. But we're good at multiplying matrices, so it doesn't take us too long to, okay, 3 and 1, 1 and 3, 6 down here. And we get 1, 0, 6, 1. Okay. Now how about if I cube it? So that would be write out 3 copies of this matrix and multiply them together. But if we're clever, we don't have to. I know what 2 copies of this matrix multiply together to, so why bother writing that all out when I could just write their result that I just worked out the line before? And now we'll multiply. So 1 and 0 and 1 and 6 gives us a 1. 1 and 0, 0 and 1, they miss each other, we get a 0. 3 and 1 dotted with 1, 6. So 3 times 1 is 3, 1 times 6, 6, we get a 9 here. 3, 1, 3 and 0 give us 0, 1 and 1 give us 1. Okay, we might start to notice some things. There seems to always be a 0. There always seem to be 1s along the main diagonal. But the bottom number, the number in the bottom left corner, seems to change. It was a 3, now it's a 6, then it became a 9. How are we getting these? And you might be able to sort of guess what it is based on what exponent you're at. Okay. How do you get a 6 using a 2 and the knowledge that we're working with 1, 0, 3, 1? Think about it for a moment. So we might guess that, oh, 3 is 3 times 1. 6 is 3 times 2. 9 is 3 times 3. So what would I guess? And this is critical to answering a question like this. What would I guess 1031 to the power 4 is? I would guess that we get the 101 where they're supposed to go, and then this should be 3 times my exponent of 4. So there's my guess. If I'm wrong, then I have to go back and reassess my pattern. If I'm right, then I think we can use this to answer the full question. But we do have to make a prediction and check it. So we'll take 1031 and we will multiply it by the one that we just worked out. 3 copies multiply together. Here. So this is our prediction. And what do we get? 1, 0 dotted with 1, 9 gives us a 1. 1, 0 dotted with 0, 1 gives us a 0. 3, 1 dotted with 1, 9. So 3 times 1 gives us 3. 1 times 9 gives us 9. 3 and 9 add up to 12. Then 3, 1 dotted with 0, 1 will just give us 1. Look at that. We made a correct prediction. If we wanted to be absolutely certain, we could then work out by hand this to the power 5, and hopefully our prediction will still be true, and we'll still get 1, 0, 15, 1. Why 15? Because 15 is 3 times 5. Okay? And if you want to make absolutely certain, you can do that and check it out. But yeah, we've got the pattern. So now that I understand the pattern, now that I understand how the powers of 1031 work, we can answer the question. They asked us for this to the power 50. So what would that be? We get the 1, 0, and 1 that we've seen every single time. And then 3 times 50. So that'll be 150. And there's our answer. And based on understanding how to do matrix powers, that gave us enough information to then start looking for our pattern. And once we had our pattern and confirmed it, we were able to answer the full question.